Okay. Yeah. Yeah. That explanation. ನೀವು ಶುರು ಮಾಡ್ಕೊಳ್ಳಿ. ಏಕೆ? ಜಾಸ್ತಿ ಆಯ್ತು. ಜಾಸ್ತಿ ಎಲ್ಲ ಸಲ ಚೇಂಜ್ ಮಾಡಿ ಮುಂಚೆಲ್ಲ ನಾನು ಕಾಂತಿಸಿದ್ರೆ 100 ರೂಪಾಯಿ ಬಿಟ್ಟು ನಾನು 15 ದಿನದಲ್ಲಿ ಎಲ್ಲ ಒಂದೊಂದು ಪೀಸ್ ಇವಾಗ ಬೇಕಂತ ಬಿಟ್ಟಿದ್ದು ಬೇಕಂತ ಬಿಟ್ಟಿದ್ದು ಆರು ಕಳಿಸ್ತೇನೆ 5ನೇ ತಾರೀಕು ಹುಷಾರ್ ಹೋಗ್ತಾನೆ ಅಂತ. ಹೌದಾ? ಕಳಿಸಿ ನಮ್ಮ ಮಗನೇ ಹೇಳ್ತಿದ್ರು. ಗೌರವ ಇಲ್ಲ ಅಂದ್ರೆ ಅವಳು ನಾನು ಕಳಿಸು ಅವಳನ್ನು ನೀವು ಒಂದು ಫಂಕ್ಷನ್ ಹೋಗ್ತೀನಿ. ಅಲ್ಲೇ ತಗೊಳ್ಳೋದನ್ನೇ ಎಡಗಡೆ ತಿರ್ಕೊಂಡು
Hello students. Yesterday we have learnt about permutations and combinations synopsis, a few formulas, some shortcut formulas also. Today we will practice some problems, questions based on permutations and combinations. Let us see how many you can do them by yourself and how many you need help. So in that way you can practice also. Let me put the first question. Here, they're asking you NPN minus 1. And the 4 options are also given to you. It must be one of them. So when you use the formula which I gave you yesterday, n factorial by n minus r factorial. One of the options you must get. N factorial by n minus n plus 1 factorial. N and minus n will cancel. N factorial by 1 factorial is 1 only, which I need not write. So the option is B. Let's go to the second question. Here is the second question. The number of ways in which 8 students can be seated in a line. Total 8 students are there. For these 8 students, there will be 8 places in a line. So 8 students, 8 places. They have to be arranged in 8p8. That is 8 factorial. 8 factorial means 8 into 7 into 6 into 5 into 4 into 2 into 1. And that would be 40,320. So option D. You must be able to, if you do practice, You can by heart up to 10 factorial. You can memorize the values up to 10 factorial. So learn that so that your process will be very quick. Okay, next question. Suppose if NP5 is 60 into N minus 1 P3, then what is N, the value of N? So write NP5 equal to 60 into N minus 1 P3. You can use the formula. Like, I'll give you one example. Suppose if you have 7P3, you can use the formula 7 factorial by 7 minus 3 factorial. That is 7 factorial by 4 factorial. Or 7 into 6 into 5 into 4. Stop here. 4 factorial by 4 factorial. 4 factorial will cancel. So finally 7 into 6 into 5 is left. So instead of using this formula, you can make yourself one shortcut formula. Because 7 is there, start with 7. Because 3 is there, take only 3 numbers, 7, 6, 5. Like that, you can make a shortcut way. So here, NP5, start with N, N minus 1, N minus 2, N minus 3, N minus 4. Total 5 numbers you are taking because 5 is there. Equal to 60 into, start with N minus 1, N minus 2, N minus 3. We are taking only 3 numbers here, 1, 2, 3. That's because down you have 3. Like this, if you do, you can make the process very quick. So both the sides N minus 1, N minus 2, N minus 3 cancels. N into N minus 4 equal to 60. You can solve this equation, but easy way is all these are given values of N. Which one will be correct? You can test. Suppose if you put N as 6, 6 into 6 minus 4, 2 will not give you 60. If you put N as 10, 10 into 10 minus 4, 6. Yes, this is giving you 60. So option B is correct. So instead of solving this equation, in place of N, you can put different values and test where you will get 60. That is another shortcut method. Shortcut method means always you need not by heart formulas. Sometimes your own brain will tell you what shortcut method can be used. But for that, as I told you, you must be good in maths. Okay, next. Next question asks you the number of squares that can be formed on a chessboard. So actually, if you have seen the chessboard, how many squares will be there on the whole? If a chessboard is like this, observe the chessboard carefully. One second. I'm erasing. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So total how many squares are there? How many rows are there? How many columns are there? Till now I have drawn 8 and 8. Now put the coins and see. Here elephant will be there. After that, one place you keep for camel, one place you keep for horse. And then minister, king, again, one more, horse, camel, and elephant. That means you have to draw 9 columns and 9 rows like this. So one will be black, white, black, white, black, white, black, white. This side also black, white, black, white, black, white, black, white, black, like this. Did I draw correct? 4, 5, 6, 7, 8, 9. Okay. Like this, the squares will be there. Now, how many squares that can be formed on the chessboard? That is what they are asking. So if you want to make squares, you need 1 into 1. That means here 1, I'll draw with red color. Here 1 and here 1. That is what you need. And if you want another square, now what you need? This side 2, this side 2, this side 2. So that 2 into 2 squares are formed. First we have taken only one red color. Now we are taking, Rakshita already told me the answer. It is 64. Total 64 squares. Let us see whether it is 64 or not. But here 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Here one extra came. Okay. Yeah. So what I was saying is, to make square, you need either 1 times 1. It will be counted as 1 times 1. Then next, here 2, here 2. So 2 square. The lengthwise 2, breadthwise 2. That is what you need. So 2 into 2 will be made. That means, what I mean is, if you take 1 and 1 here, you will get 64 squares. What Rakshita did, that I am telling you. In first case, red color. If you take all these 1 rows and 1 rows, 1 by 1, if you take, total 8 into 8, 8 square, that is 64 squares will be formed. But after that, still you can go to the second one, 2 into 2, this way. So the second option is 2 by 2. When you take 2 by 2, 7 squares, 7 into 7, 49 grid squares will be formed. You may be thinking in a different way. You may be thinking that These 8 and these 8 already I have multiplied and I got 64 squares. But that I am talking about only 1 squares. The red color squares which I am counting, they are only like this, 1 squares. But when I'm taking 2 into 2, what am I counting is like this, 2 squares making a big square. 2 squares making a big square like this. And after that, 3 squares also can make a big square. I'll show you with green color. 3 squares here, 3 squares here, like this. A big square can be formed. Those will be 6 square. When you include the third row also, 3 square. Like that, if you continue making 4, 4, 5, 5, 6, 6, 7, 7, 8, 8 squares. When you take 8 squares, in the end, this is the big square formed. So 8 square plus 7 square plus 6 square plus 5 square plus 4 square plus 3 square plus 2 square plus 1 square. So Shivu also told me one answer. Let's see whose answer will be correct. The one which we got here is sum of squares of n natural numbers. The formula for this is n into n plus 1 into 2n plus 1 by 6. But here we have only up to 8, not n, 8. So 8 into 8 plus 1, 9 into 2 into 8 is 16 plus 1, 17 by 6. So 3 3s, 3 2s, 2 1s, 2 4s. You are multiplying 4 into 3 into 17. And as Shivu said, it is 204. Still, if you have doubt, yes, correct, Rakshita. So still, if you have doubt, you might have seen in permutations formula where I have given you this n power r. Repetition is allowed. N power r. Total n squares are there. Out of that, you are taking r squares at a time. Repetition is allowed. That formula also you get. Okay. Next question. The number of ways 4 boys and 3 girls can be seated in a row so that they are alternate. So boys, I will take B1, B2, B3, B4. Girls, I will take G1, G2, G3. Now total I need 7 space, 7 places, 7 seats, 7 chairs. 4, 5, 6, 7. They have to sit in an alternate way. So first I can make the boys sit because they are more in number. Boy 1, boy 2, boy 3, boy 4. They went and sat. So they have 4 places. There are 4 boys. They can be arranged in 4 factorial ways because this boy can sit here, this boy can come here, this boy can go there. Like that, they can be shuffling among themselves in 4 factorial ways. After the work of boys is over, still the work is not complete. Only first work we have done. Fundamental counting principle. The second work is making the girls sit. 3 places, 3 girls. That can be done in 3 factorial ways. Again, they will arrange. So total 3 factorial ways for the girls. Now the whole work is completed. So you will multiply 4 factorial and 3 factorial. What is 4 factorial? I said you have to by heart. 24. What is 3 factorial? 6. And when you multiply 24 and 6, you will have 144 ways. Okay, sorry, there was a disturbance. Okay, next. This is the next question. The number of ways 10-digit numbers can be written using digits 1 and 2 is. So 10-digit numbers are there. That means 10 places, 4, 5, 6, 7, 8, 9, 10, 10 places. But in these 10 places, you have to fill up only 2 digits, 1 and 2. That means repetition is allowed. You have 2 digits. When repetition is allowed, if you use 1, if you use the digit 1, then how many chances it will have? 1 can be sitting in how many places? And if you use 2, how many places? This is N, this is R. So repetition is allowed means what? Each place can be filled in 2 ways. This place can be taken 1 or 2. This place can be filled in 1 or 2. Here 1 or 2, here 1 or 2, here 1 or 2, here 1 or 2, because repetition is allowed. So when repetition is allowed, this can be filled in 2 ways, 2 ways, 2 ways, 2 ways, 2 ways, like that 10 times. And then it will be 2 power 10 ways. So this is the explanation. Okay, next. A coin is tossed n times. The number of all possible outcomes. Same way. N times. We are tossing n times. N places are there. When you toss the coin, there are only 2 possibilities, head or tail. So first time, head may come or tail may come. Second time also, repetition may be allowed here also. Head or tail. Head or tail will come. Head or tail. So 2 ways, 2 ways, 2 ways, 2 ways, like that n times. So total number of possible things is 2 power n. Option B. Next question. In how many ways 8 distinct toys can be given among 5 children? So the number of toys is 8. Total you have 8 toys. And number of children are 5. They did not give you any condition. Like one child should get only one toy. Like that they did not give you. If some condition is given, we will think about that. So if 5 children are standing in a row, so the first child can get any one of the 8 toys. Second child can get any one of the 8 toys. Third, any one of the 8 toys. Fourth, any one of the 8 toys. That means 8 power 5 ways. If they give you some condition, then repetition will not be allowed. Then you can't use this formula. We will see, we'll come across that kind of problems also. Here, there are 10 true false questions in an examination. These questions can be answered in how many ways? Total 10 questions are there. 4, 5, 6, 7, 8, 9, 10. You have to answer true or false. Again, there is no condition given to you. First question, you can answer true or false. Your way. True, false. Anything you can answer. They did not say that all the questions need not be true, all the questions need not be false, or some questions are true, some questions are false. That they did not see any condition. So, 2 ways, 2 ways, 2 ways, like that 10 times, which will be 2 power 10. And what is 2 power 10? 1024. These also you must by heart. Like 2 power 1 is 2. 2 square is 4. 2 cube is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. 2 power 7 is 128. Like that you must 256, 512, 1024. All these you have to memorize it up to 2 power 10. Then it will be easy for you. Shivu, did you understand now? It is 2 power 10 means 1024 because 2 power 7 is 128. 2 power 8 is 256. 2 power 9 is 512. You did only 2 power 9. 2 power 10 will be 1024. 1024 is a magical number actually. In cell phones and all, Play Store you can see. There will be one game. In that game, like if 4s are there, 2 4s come together, they become 8. They sum up and an 8 box will come. 8 and 8 if they come together, they sum up and they become 16. Like that, the one game is there. You can play that game and see. It will be very interesting. 1024. After that, it will be double also. 2056 also is there in that game. 2 power 11 is also there in that game. Okay. We will leave about the game. We will go to the next question. Here is the next question. In how many ways can we paint 6 faces of a cube with 6 different colors? See, here there is a condition. 6 different colors. You can't use the same color. So let us take the 6 different colors as color 1, color 2, color 3, color 4, color 5, color 6. 6 different colors are there. Assume that the face of the cube is facing up is color 1. That means if I draw the cube like this, the cube which is coming up, this is color 1. That is what I meant. So the face of the cube at the bottom can be painted in 5 different ways. Because here 1, 2, 3, 4, 5. This bottom one can be painted. Okay, color 1 you have painted here. On the top you have painted color 1. So if you take the bottom one, it can be painted in 5 different ways. You can use color 2, color 3, color 4, color 5, color 6, because color 1 is already done. Now, 4 faces on the horizontal side of the cube are in circular permutation. These 4 faces, 1, 2, 3, 4, they are forming a circular permutation. So in circular permutation, what happens? We have used color 1 and we have used another color here. So say color 1 and color 2 we have used. For example, now only 4 colors are left, but this is circular permutation, right? So the remaining 4 faces can be filled in 4 minus 1 factorial, because in circular permutation, n minus 1 factorial is the form. So first work, bottom face in 5 ways, and second work, circular permutation, 4 minus 1 ways. So total number of ways, fundamental counting principle, total work. This is the first work, this is the second work. 5 into 3 factorial, that is 30, because 3 factorial is 6. In 30 ways you can paint. Okay. Let us go to the next set of questions. Slowly, the questions level is increasing. I'll put the next question. Oh, it's too big. Yes. This question is saying, in how many ways 8 Indians, 4 Americans, and 4 Englishmen can be seated in a row so that all persons of the same nationality sit together? So Indians are 8. I1, I2, I3, I4, I5, I6, I7, I8. Americans are 4. A1, A2, A3, A4. Englishmen are 4. E1, E2, E3, E4. So the places are already given like this. They are sitting in their places, because what is the condition? Persons of same nationality sit together. See, all the Indians are sitting together, all Americans together, all Englishmen together. They're sitting together. So already I have arranged them in that way. Now for Indians, 8 places, 8 Indians in 8 factorial ways they get arranged. For Americans, 4 places, 4 Americans, they can arrange in 4 factorial ways. For English people, 4 people, 4 places, they will arrange in 4 factorial ways. Okay, but 3 works are there, we have done. There are 3 works, we have done the 3 works, we are multiplying. But you forgot one thing. This is like a bundle. This is the second bundle. This is a third bundle. Bundle means group. 3 groups are there. Now, these 3 groups can interchange. Like this group can come in the middle. This group can come first. Like that also can take place. So 3 groups can arrange in 3 factorial ways. It can shuffle in 3 factorial ways. So the option A would be the correct. Let me put the next question. Okay. This question tells us how many permutations of the word, of the letters of the word apple are there? If you take this apple word and arrange the letters, shuffle them, how many ways you can do it? Of course, you will not get meaningful words. Like apple is a meaningful word. This arrangement is a meaningful word. But if I arrange E here, L here, A here, and PP here, it has no meaning. But still arrangement, they're asking. So total 5, 3, 2, 5 are there. Total 5 letters are. I have counted total 5 letters. But there is one special condition here. P's, 2 P's are there. Repetition. P is coming 2 times. So when you take arrangement, it will be 5 factorial by 2 factorial. Because P is coming 2 times. 5 factorial is 120. 2 factorial is 2. So answer will be 60. So every question, if you see, there will be a condition hidden over there. If there is no condition, that means repetition is allowed. Okay, next question. Okay. How many different words can be formed using all the letters of the word Allahabad? So if there is no condition, first question, no condition. In Allahabad, total how many letters are there? 3, 6, 9. Total 9 letters, alphabets are there. Out of that, A's, how many times they are coming? A's is being repeated. How many times? 4 times. L's are also repeating. How many times? 2 times. So without any condition, if you see, 9 factorial by 4 factorial, 2 factorial. This is the number of arrangements. Now you have to simplify this because the answer is given in a different way. So 9 into 8 into 7 into 6 into 5 into 4 factorial by 4 factorial into 2. 4 factorial and 4 factorial will cancel. Then 2 4s. So 9 4s, 36. Then 7 I will keep separately. 6 into 5 I will make 30. So that 36 into 7 into 10 will be 210. Now multiplying this 36 into 210 is very easy. 7,560. These are the number of words formed. Of course, they won't be meaning. Okay. Now, next condition in A, what they gave? When vowels occupy the even position. So, one condition for A is 9 letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. First position, second, third, fourth, fifth, sixth, seventh, eighth, ninth. The main condition is for vowels. What are the vowels present here in the word Allahabad? A is I'm putting vowels here. Vowels means A is a vowel. Only A, nothing else is there. But there are 4 A's. So A's are occupying even position, 4 A's. Second position, fourth position, sixth position, and 8th position. Vowels are occupying even places. Now, in how many ways they can be arranged? There are 4 vowels. So, in 4 factorial, but they are repeating 4 times. So, 4 factorial. So, first work is done. Now, coming to other letters. What are the other letters? Consonants. The other letters are consonants. That means L, L, H, P, T. 5 letters. For these 5 letters, 1, 2, 3, 4, 5 places are there. 5 factorial. But 2 L's are there. So 2 factorial. First work, second work, done. Of course, this is 1. 5 into 3 into 2 factorial by 2 factorial. So 15 words can be formed when vowels are occupying even position. Okay. I think I missed one. Sorry. I missed 4. 5 into 4 into 3 into 2 factorial. Yes, I forgot 4. So 5 into 4 into 3 means 60 words can be formed here. Okay, this is over. Now the next condition is both L do not occur together. So this condition is both L do not occur together. But what will happen if L's occur together? Let us see what will happen. 1, 2, 3, 4, 5, 6, 7, 8, 9 places are. 1, 2, 3, 4, 5, 6, 7, 8. Now suppose if both L's occur together, then in how many ways you can arrange them? 2 L's are there, 2 factorial. Total, we have 2 letters. Total 2 letters L, 2 factorial. And again, because they are repeating, 2 factorial. So for L's, we have considered. We have already taken. Now, the remaining is the other 8 letters. Why am I saying 8 letters? Because if I take out 2 L's, what is left? H, B, D is left. Then A are left. And then L is forming 1. Right? Why am I counting this L? I'll tell you. Already I have arranged LL. But why am I counting LL again? This LL can sit here. The LL can sit here in between B and D. Or here. or here, or here. This LL will change again. Right? It will not be in the first two places only. It can be in the second, third. It can be in the third, fourth. It can be in fourth, fifth. Like that together, I'm bundling this. I'm grouping this LL. So now how many letters I have? 1, 2, 3, 4, 5, 6, 7. And this one, 8. Total, I have 8 letters. Now, I am taking these 8 letters, out of which A's are coming 4 times. So I can arrange them in 8 factorial by 4 factorial ways. So this is how first work and second work. It is multiplied. So here 1 I have 1 into 8 into 7 into 6 into 5 into 4 factorial by 4 factorial. 4 factorial and 4 factorial will cancel. 8 7s 56, 6 5s is 30. So 1680 words can be formed here. But these are else together, else not together, opposite. Total in the beginning without any condition, total 7560 words. From 7560 words, you subtract this 1680 words. Total without any condition, 7560 words can be formed. Out of them, else together 1680. That means else not together will be left off ones. And left off is 5880. So we have 3 options. First one, I'll color with green. First answer, 7560. It is present in the first option. Second one, answer I got 60. It is present in the A option. But for third one, I got 5880, which is not there anywhere. So option D is the correct option. None of these. It's not a big number. Like in the options, 3 answers are given separated with column. It is not something like 70 crores. The answer is not like that. Let's go to the next question. Here is the next question. So in this question, in how many ways 10 examination papers be arranged so that the best and worst papers never come together? So total 10 examination papers are there. E1, E2, E3 up to E10. Without any condition, they can be arranged in 10 factorial ways. But the condition is best and worst papers never come together. In these 10 papers, only one paper can be best and one paper can be worst. There can't be many best papers, many worst beings. So best and worst come together. We will take best and worst come together. So if you bundle them, if you group them, then you will have E1, E2, only 8 papers are there. The left top. Already best and worst we have taken, total 10 are there. So 8 papers are outside the group, 2 are inside. But we can count this as together one bundle, one group. So 1 and 8, total 9 papers are there. Imagine 9 papers are there and they can be arranged in 9 factorial ways. But in this arrangement only, best and worst can exchange. They can rearrange in 2 factorial ways. So this is best worst together. But they are asking never together. So from total, you have to subtract together. But this option is not given there. So what I will do is, I will take 10 factorial as 10 into 9 factorial minus 9 factorial into 2 factorial. I'll take 9 factorial common, left is 10 minus 2. That means 8 into 9 factorial. It is option A. Okay, you can see it for some time till I paste the next. Okay, here is the next question. In how many ways 4 boys and 3 girls can be seated in a row so that they are alternate? I think this question already we did. It is repeating. So let me put the next question. Here. A 2-member committee comprising of 1 male and 1 female member is to be constituted out of 5 males and 3 females. Amongst the females, Mrs. A refuses to be the member of the committee, in which Mr. B is taken as a member. In how many different ways can the committee be constituted? So actually there are 5 males and 3 females. Out of that, you have to make a 2-member committee group. And this group must have, very important, 1 male, 1 female. So what will happen? You have to select. This is not arrangement. You have to select 1 male. From 5, you will select 1 male. So it can be happen in 5C1 ways. One work is over. After that, from 3 females, you have to select 1 female. Okay. And then, but there is a condition. A cannot come whenever B will be coming. That means out of A and B, only one will come. So there is one case where both A and B are selected. Suppose by chance in males B is selected and in females A is selected. Both are coming. That can happen only in one case. Because this is not arrangement, this is selection. So that one case has to be subtracted. Okay. So what is 5C1? Short form you must learn, 5. What is 3C1? 3. 15 minus 1, 14 ways out. You must know what are C1s also. Very quickly you must be able to add. Shivu, what happened? You got disconnected in the middle? Can you hear me, Shivu? Okay, let it be. In the middle, you got disconnected. That's what I was asking. Anyways. Let's go to the next one. Okay, network, fine, no problem. Yes, next question. Okay. In how many ways 2 students can be chosen from the class of 20 students? Okay. This is very, very simple answer. From 20 students, you have to select 2 students. But now I will tell you one shortcut method. Actually, according to the formula, what you will do? N factorial by R factorial into N minus R factorial. That is 20 factorial by 2 factorial into 18 factorial. That is 20 into 19 into 18 factorial by 2 into 18 factorial. This will cancel. 2 tens you have, and then 190 will be the answer. That is option A. But anyways, what I want to tell you, the shortcut method is, suppose if you have 20 C2, start with 20, take only 2 numbers, 20 and 19, and divide by 2 factorial. This is the shortcut. Suppose if I have 7C2, what I will do, start with 7, take only 2 numbers, divide by 2 factorial. So 2 ones, 2 threes, 21 will be the answer. Suppose if I have 7C5, this 5 is very big number. That means I have to start with 7, take 5 numbers, 7, 6, 5, 4, 3. What is shortcut in that? And by 5 factorial. This is nothing a shortcut. It is a long one only. So instead of that, what you can do is you can write this as 7C. 7 minus 5 is 2. Instead of 7C5, you can write as 7C2 also. And then you can write it as start with 7, take 2 numbers by 2 factorial. This is 7C5, this is 7C2, both. Suppose if you want to check, you check in the long way also. 7, 6, 5, 4, 3. Take 5 numbers. Divide by 5 factorial. 5, 4, 3, 2, 1. 5, 4, 3 will cancel. The same thing you got. 7 into 6 by 2 into. Similarly, if you take 10C8, it is same as 10C2. If you take 10C3, it is same as 10C7. Or 10C7 is same as 10C3. Like that, you can go for shortcut methods. That is the main thing I wanted to point out at. Okay. Next question. Today we are not going to high level questions because this is just the first today. I did not copy the options. I think this will be the last question we can do. Quickly, we will do it. We don't have much time. 3 gentlemen and 3 ladies are candidates for 2 vacancies. A voter has to vote for 2 candidates. In how many ways can one cast his vote? So total 3 men and 3 ladies. There are 2 vacancies. A voter can vote for both the candidates, men, ladies. 2 candidates are men and ladies. In how many ways one can cast the vote? So total there are 6 candidates, 3 plus 3. 6 candidates are there. Out of 6, there are 2 vacancies. So a person has to select 2 people. Out of 6, he will vote for any 2 people. He has to say, he need not arrange. But what is the problem here is when he is taking 6C2, the shortcut method, start with 6, take 2 numbers, 6 and 5, divide by 2. So 3 into 5, 15 ways he can say. This is how you have to use the shortcut method. Your problem will be gone. Instead of doing in a long way. So today I'm not giving you homework, but tomorrow after having enough practice, I'll give you a lot of, not tomorrow, Monday, I mean. So see you on Monday. We'll end the class.